Hey everybody, I got a cooler from Be Quiet. Let's get this thing out of the box. This is the first liquid cooler from Be Quiet. If you know anything about Be Quiet, they've got some very capable air coolers, which they've had for years. But this is the first liquid cooler called the Pure Loop. And this one here is 360, but it comes in a 120, 240, 280, and of course the 360 flavors. So it will be really interesting to see how they approach liquid cooling. So we'll start by taking a look at the specifications on the side of the box. So looks like your major sockets for Intel and AMD are covered. The pump speed is 5,500 RPMs. A couple of connectors there that are 3-pin for the pump and the LED. The fans are 120 millimeter. Fan speed 2,000 RPMs, and they're 4-pin PWM. So now let's get the box open and take a look at all the details here. Alright, so as I bump the tripod, there are the 3 fans, and like they said, they are 4-pin PWM fans. These are the Pure Wings 2, if anyone is interested. And yeah, 0.3 amp draw, 12 volt, 2,000 RPM. Here's the little manual. And this actually looks like it's pretty involved, so it's a good idea to review these before you really tear into the system. Even if you've done this many times and you think you know what you're doing, sometimes there's some good information in there. And there's a hardware box. I've always been impressed by the way Be Quiet packages their products. They do a real good job of separating all the components. So here's some fan connectors. Usually this is like a 3-into-1, so you can control all 3 fans through one motherboard connection. Some fan screws, all your base plates, mounting brackets, a little bit of thermal paste, and they actually even give you a little bottle of coolant to top off the cooler, which is unusual because most of your closed all-in-one coolers, the closed loop coolers here, or closed system coolers, they don't come with any extra coolant, typically. And here is the radiator and pump. There's the base plate. They always have a protective sticker on them, so you always want to make sure you peel that off. Sometimes it's easy to get excited with a new system. You're putting it all together, and sometimes people will leave this plastic cover on there and can't figure out why their thermals are absolutely through the roof even at idle. That's because your heat can't get through that plastic. And then there's a nice protective cardboard cover around the radiator. And then there's the fill port right there. And the fill port, of course, is where you would add your coolant, top off your coolant if you need to. All the all-in-one coolers I've ever had, I have to say I've never had to top off the coolant. During normal usage, I did drop one. I've got a video about that and repaired it, so I had to put the coolant back in. But maybe I needed to add it and I just didn't realize it, but it's nice to have. Now, one thing you may notice, there's this, I don't know what you call that up there, kind of an odd looking thing, and it has a wire going to it, and there's a good reason. Cable here, a power cable. This is actually the pump, not down here on the cold plate, which pretty much every other cooler in the world, the pump is down here, at least on an all-in-one, the pump is incorporated down here into the cold plate. And I'm a little surprised by that. But Ace is a company that makes these pumps, and they've got a lot of patents. So to get around the patents, you've got to come up with something a little different. And I have to say, this is definitely something different. So I can see here one of these lines is free to sort of slip around. So it looks like all the business is happening on one side. So the pump's in here, so it's moving the coolant up into the radiator that direction. And then the other line coming here from the pump, it's just 2 wires on this 3-pin connector, and this is the power for the LED. And you can see there's a little clear trim piece around the top of this brushed aluminum cover, and that's to light up. So it's like a white LED that lights up around there. Having the pump up here, they say it's a double decoupled pump. They also do that in an effort to help reduce vibration, but I would say that of all the coolers I've ever looked at, I've never really had one that has the pump down here in the cold plate. I've never had one that really vibrated or made noise to where I was concerned about it. But again, not a bad idea, something different. So right now I'll go ahead and get the test system built up, and what that consists of is this Z390E Asus motherboard with a 9900K CPU on there, and we'll get that cranked up. Alright, so I've got the mounting bracket on there for this socket. That was pretty easy to do. I'll get that old thermal paste cleaned off there and get a fresh application, and again, don't forget to peel off the sticker. And there is the cold plate with the sticker off. This is nickel plated. Typically these are just pure copper. Now that doesn't mean that the material is not copper with nickel plating on it. That's a very common thing to do with copper. Regardless, they do that supposedly to improve the thermal transfer between the CPU, the thermal grease, and the cold plate. So we'll see what kind of an effect that has, if any. But my guess is if the engineers went to the trouble to nickel plate that, they obviously have a good reason. So let's get this thing installed and put some heat to it. And for anyone interested, the way these coolers work, your radiator actually has a baffle right here, so it separates into 2 sections. And your coolant comes in on one side, it travels down one half of the radiator. When it gets to the bottom, it makes a turn down here in the bottom, so this bottom tank is completely open. So the coolant makes the turn and then comes back to the other side. The other half of this chamber on this end tank is actually, like I said, there's a baffle in there that divides it. And then the coolant that has hopefully been cooled exits and goes back to the CPU. So your coolant, even though it's a 360 millimeter radiator, it's actually traveling 360 millimeters down and 360 millimeters back. Alright, so I have the system powered up, no issues at all. I've got the cord here, or the cable, plugged in for the light, and it actually has a separate SATA cable here that you run over to your SATA power, so you don't have to plug the pump or the LED light directly into your motherboard. So that saves you some fan space. And then the fans themselves, they all come together here into this. Actually, it's not that, it's this one right here. This one brings all 3 fans together and connects them to your motherboard, your CPU fan header right there. So that way all 3 fans are controlled, again, from a single source. Now I will tune the fans, and I'll bring up the spec sheet here so you can see the test system specs. And it's always a good idea to go ahead and run through the fan tuning software of your motherboard. That way your fans are set up to run optimally. So let that run for a moment. So it's still doing the fan tuning procedure. Usually the fans come to a complete stop at some point, but those are moving pretty slow. fan tuning operation is done. So we'll go ahead and get the overclock cranked up and see how this cooler handles the heat. Alright, so I leave the stress test run for a while to get the thermal soak of all the coolant so that everything's up to temperature. Have the fans cranked up to their maximum RPM, which is 2000. And we'll take a quick look at some decibel levels. It's on the intake side, and let's look at the exhaust side. Temperature-wise now I'm holding at about 56, 57 degrees Celsius, which is about what I expected. And it kind of switches between 56 and 58, so we can probably call that an average of around 57. Okay, thermal imaging time. Here's the fan side. You can definitely see the hot spot where each one of the little fan motors is. I keep it about 20 degrees Celsius in here for the testing. You can definitely see the hot side of the tank where the coolant's coming in, and the cool side of the tank where the coolant is leaving. We can tell that, like I was saying earlier, the hot side comes in on the right top there, and it travels down the length of the radiator where it slowly loses heat, shifts to the left, and then comes back up the left side, or the left half, where it exits at a cooler state, usually about 3 to 4 degrees. And you can see the pump motor right there. You can definitely see where the electric motor is, that little hot spot right there. And you can surely tell which one of these lines is the hot side and which one is the cool side. And looking a little more closely here at the fill port right there, you pop that screw out. Usually there's a little rubber seal underneath it, or a little gasket, and that is where you would top off your coolant if you need to, using the supplied coolant right there. And I got the screws out of the top and bottom cover for the pump, and there's the pump. Not terribly exciting, but you can see obviously the electric motor is over here on this side, and this is where the thermal camera showed that little hot spot. And that's about all there is to it. And again, this is the first shot at liquid cooling here from Be Quiet. The Pure Loop comes in several flavors, starting with a 120 millimeter. Next is a 240, then a 280, and then finally this one, which is the 360. And like I said, the pump runs at constant speed, and I mean, I'm standing right next to it, and unless I put my ear right up against it, I mean, you can hear the sound basically of an electric motor running, but you'll never hear it once this thing is inside of a case. And like I said, I'm standing right next to it, and I really can't even hear it. So given the performance and the price point, I would give this the Overclockers Club Gold Award. So this is Chris with Overclockers Club. Thanks for watching, and don't forget to subscribe.